In this video, we're going to explore how to solve a system of equations by substitution. So I'm going to go and look at a couple examples. Some of them we've already done, and we're going to see how this method works. And we will continue to refine and perfect and work with this method throughout the next couple of weeks. So let's just start with the basics. So first of all, when we solve equations, systems of equations, what we've been doing is solving by graphing. And so when we saw this y equals 3x minus 1 and y equals 2x plus 1, what we've been doing is drawing a coordinate plane, finding the slope and y-intercept of one of the lines, finding the slope and the y-intercept of the other, finding where they intersect, and finding the solution that way. Sometimes that doesn't give us a super accurate solution, though, as we saw in a lot of the word problems. So today I'm going to introduce another method. So substitution is a word we've already learned when we're talking about evaluating expressions. So when I say evaluate 2x plus 1, when x is 5, you substitute 5 in for x and evaluate. So substitution is just to replace, right? So when we solve by substitution, what we're going to do is we're going to replace a variable in one equation with an equivalent value from the other. So substitution is to replace a value in one equation with an equivalent value from another. These first types of equations we're going to look at, the substitution is fairly straightforward, and then as we get confident and better, what we're going to do is make it a little bit more complex. So looking at this system right here, notice how they are both in y equals form. And for our solution, our system to have a solution, the y value and the x value are the same in both equations. That's where the two graphs meet and they cross and they intersect. So what we're going to do is we're going to say to ourselves, if this equation, the y values are equal to 3x minus 1, and in this equation, the y values are equal to 2x plus 1, well, I can take the y in this equation and replace it with the value of y from the other. So now I'm going to erase this y, and I'm going to put its equivalent value, 2x plus 1, there. So basically, I've set the two equations, I've set the 3x minus 1 equal to the 2x plus 1 because both of those are equal to y. And again, the solution to the system would be when the x and y value are exactly the same for both equations. Well, this is exciting. This is an equation with variables on both sides, and we know how to solve this. We solve it with algebra, and we can get a really exact solution, which is a theme we've been talking about all year. Algebra gives us exact solutions. Graphing gives us trends, and it gives us estimations, but sometimes it doesn't give us exact. So you can solve this any way you want. I'm going to start by subtracting 2x. And then I'm going to add 1, and I get x equal 2. So this is great. I got the value for x, which is 2. I'm not done yet, though, because now I need to get the value for y. I can pick either of these two equations to use to get my y value. So I will show you both just for the sake of argument. So again, because I solved for x, I go back to this equation and I substitute 2, which was my solution value for x, into the equation, and I get y equals 5. If I were to substitute 2 in for x in the second equation, 2 times 2 is 4, and 4 plus 1 is also 5. So I do get the same y value no matter which equation I used. If I didn't, that would actually tell me something is wrong. Because remember, again, the solution, the graphs cross on the same point, the x and y values are going to be the same. So that means we have to put the two parts together once we're all done. So the solution to this equation then is the 0.25. And this was actually from homework number 51. And if you want to go back and look at homework 51, we solved it by graphing, and the solution was 2.5. So I want to do one more example, and then I'm going to show you a quick word problem that we've already done as well. So our second example, we're going to look at y equals negative 4x minus 3 and y equals negative 2x plus 1. Both of these equations, again, are in slope-intercept form, so they're set equal to y. Again, we're going to look at other equations soon where this is not the case, but for now, this is going to be the start of this process for us. So once again, because both of these expressions, negative 4x minus 3 and negative 2x plus 1, are both equal to y, we can go ahead and set them equal to each other. And then we will solve this equation for x. So I'm going to go ahead and add 2x to both sides. That gives me negative 2x minus 3 equals 1. Then I'm going to add 3. So negative 2x equals 4. And finally, dividing gives me x is negative 2. So that is my x value of my solution. For the second part of that solution, remember I need to get the y value. I can go back to either equation and substitute x equals negative 2 in. So I'm going to go ahead and go to this one. So y equals negative 2x plus 1, substituting negative 2 in for x. Negative 2 times negative 2 is 4, and 4 plus 1 is 5. Very similar to the first one. I didn't intend that, but that's what happened. This, however, has the solution of negative 2, 5. And if you would go ahead and graph these equations, like we've done before, that's where you would see the intersection point. So now what I want to do is I want to take a look at a word problem where we've kind of only been able to estimate the answer, and now we're going to get the exact answers. And this is something we're going to pick up and start in class on next week. So Eric sells model cars. Do we remember Eric? Maybe you do, maybe you don't. Eric sells model cars at a local flea market. He purchases them from a distributor for $12, and he has to pay his booth fee of $50. He's selling the model cars for $20. So this was the system we came up with. X was the number of model cars, Y was his money, Y equals 12x plus 50, those were his expenses, and Y equals 20x, that was his income. And we were able to estimate, again, where Eric's break-even point is, which is what we're going to get out of this, except for now we're going to get his exact break-even point. We don't need to estimate. Because everything is written in slope-intercept form, we set the two expressions, 12x plus 50 equal to each other, equal to 20x. Again, this is equal to y, this is equal to y, and we're looking for where the y and x values are the same, so we can go ahead and set the y's equal to each other. I'm going to subtract 12x from both sides. And as we can see here, this is not going to be a whole number. And that's because, again, when we use the graph, we only got an estimate. So if I take 50 divided by 8, I get 6.25. And remember, that is the number of model cars Eric needs to sell to break even, to have his expenses and his profit equal the same amount. So what is that amount? Well, because I get to pick either equation, I'm going to go ahead and pick y equals 20x because I only have to do one thing. And I'm going to go ahead and substitute 6.25 in. And so that means if Eric sold 6.25 cars at $20 a pop, he would make $125. So my exact break-even point is the point 6.25, 125. And so again, if Eric sells 6 1/4 model cars, he will make $125 and his expenses will equal $125. So that's his break-even point. Now we all know you can't really sell 6.25 cars. And so when we're working with word problems, of course, we would have to just interpret that expression. So really what this means is, you know, if he sells 6 cars, he's losing slight money. So if he sells 6, he loses a little money. And if he sells 7, he's starting to make a profit. But it would be a very small profit, right? Oh, sorry about that. So we're going to take a look at the other word problems and, again, practice this method. But this was an introduction to solving systems of equations using the substitution method.